In today's lecture, I will discuss about reasoning in artificial intelligence. In this lecture, I will cover reasoning in AI and types of reasoning. The reasoning is the mental process of deriving logical conclusion, making predictions from available knowledge, facts, and beliefs. Or we can say reasoning is a way to infer facts from existing data. It is a general process of thinking rationally to find valid conclusions. So, in artificial intelligence, we are building intelligent machines which could automatically take the decisions. For that, we are maintaining the knowledge base, and in that knowledge base, we store so many sentences. Now, what we have to do? We have to extract some kind of meaningful information, or we have to make some kind of decision making, or to find conclusion from those sentences, and for that purpose we have to do the reasoning. Artificial intelligence, the reasoning is essential so that the machine can also think rationally as a human brain and can perform like a human. So there are different types of reasoning in artificial intelligence. First is deductive, then inductive, abductive, common sense reasoning, monotonic reasoning, and non-monotonic reasoning. First one, deductive reasoning. Deductive reasoning is deducing new information from logically related known information. For example, we have fed some sentences in form of propositional logic in artificial intelligence, and what we have to do, we have to find a conclusion from those sentences. For that, we are performing deductive reasoning. For example, in the first sentence it is written that all the human eats cheese, and in the second sentence Suresh is human. So from these sentences we could able to conclude that Suresh eats cheese. Second type of reasoning is inductive reasoning. Inductive reasoning is a form of reasoning to arrive at a conclusion using limited set of facts by the process of generalization. Inductive reasoning is a type of propositional logic which is also known as cause-effect reasoning or bottom-up reasoning. In inductive reasoning, premises provide probable supports to the conclusion, so the truth of premises does not guarantee the truth of the conclusion. So basically, in such type of reasoning, we are not getting the complete information from the sentences that we stored in the database. For example, all the pigeons we have seen in the zoo are white. So based on this sentence, we are trying to conclude something, and we are concluding that therefore we can expect all the pigeons to be white. So in this, we are having a limited knowledge, and we are just aware about the pigeons which are in the zoo, but the color of the pigeons which are outside the zoo, we are not able to judge. So in this, we can say that in inductive reasoning, we does not guarantee the truth of the conclusion. Third is abductive reasoning. Abductive reasoning is a form of logical reasoning which starts with single or multiple observations that seeks to find the most likely explanation or conclusion for the observation. Abductive reasoning is an extension of deductive reasoning, but in abductive reasoning, the premises do not guarantee a conclusion. For example, cricket ground is wet if it is raining. This is the first sentence, and in the second sentence, cricket ground is wet. So from these two sentences, we are concluding that it is raining. Now this statement could be valid or it cannot be valid all the time, because in this again we are having a limited knowledge, and we could not guarantee that the conclusion or the inference that we have done is completely correct. Fourth type of reasoning is common sense reasoning. Common sense reasoning is an informal form of reasoning which can be through experiences, and basically such type of reasoning is heuristic in nature. For example, one person can be at one place at a time. So this is very common sense type of this statement is a kind of statement which possesses common sense, and such type of statement could be easily understood by the human beings because we learn from the experiences. So in this statement, one person can be at one place at a time. If I put my hand in a fire, it will burn. So these two statements belongs to a common sense reasoning, and these could be easily done by the human beings. So the challenge is how to perform such type of reasoning from the machine. Fifth type of reasoning is monotonic reasoning. In monotonic reasoning, once the conclusion is taken, it will be remain the same even if we add some more information to the existing information in our knowledge base. So in monotonic reasoning, what is happening, if you are feeding some statement and the meaning of the statement is complete, for example, earth revolves around the sun. So whenever you are feeding this statement, the meaning of the statement will not change while adding other statements. For example, we add another sentence like moon revolves round the sun. So moon revolves round the sun has nothing to do with this statement which is saying that earth revolves around the sun. So the meaning of this sentence is not changing as we are adding more and more sentences. Such type of reasoning is monotonic reasoning. Non-monotonic reasoning. In non-monotonic reasoning, some conclusions may be invalidated if we add some information to our knowledge base. Non-monotonic reasoning deals with incomplete and uncertain models. Human perceptions for various things in daily life is a general example of non-monotonic reasoning. For example, birds can fly, penguins cannot fly, Pitty is a bird. So from these three statements we could able to infer that Pitty can fly. But now what is happening, I am adding one more sentence, and the sentence is Pitty is a penguin. Pitty is a penguin. So which concludes that Pitty cannot fly. So if we are having these three sentences, so from these sentences we are inferring that Pitty can fly. But as soon as I added the fourth sentence, and the fourth sentence is Pitty is a penguin, now there exists a kind of contradiction, because as you added this fourth sentence, it is saying that Pitty cannot fly, so it invalidates our conclusion.